We're live here today on Twitch on the Battlesnake official Twitch channel. We're going to be talking again to Colin Walker from AWS. He's also a strong supporter of the Battlesnake community and also one of the original architects of the current Battlesnake engine. So we're super lucky to have him on the channel. He's going to talk to us about how he built and some of the details about how he built his Learn to Battlesnake tutorial. We're also going to walk through how to get up and running with Battlesnake using JavaScript, using the tutorial that he built, as well as deploying to AWS Lambda. So super excited for this. We did this tutorial yesterday, and it went very well. We had a lot of positive feedback. We're going to do it again today, and we're going to go a little bit further and see what we can do to make the snakes a little bit smarter.
Hey, how's it going, Brad?
Hey, I'll let's get you on camera. I'll stop the screen share here. How's your Sunday going?
Pretty good. Yeah? Just staying at home and coding, as we should be.
That's a pretty good Sunday.
Mm-hmm.
I've got a little slide here. Let's talk about you and talk about your background a little bit and talk about how you got involved in Battlesnake and kind of where you're at now. I'll bring this slide up here. Yeah, there we go. All right, yeah, give us an idea of how you got into programming and the different roles you've had, and then how you've been involved in Battlesnake over the years.
Yeah, so I've been involved in Battlesnake for 3 or 4 years now. Started when I joined Send with us 3 or 4 years ago. I really liked the aspect of Battlesnake because a bit of my background, I'm a self-taught developer. And so I've always been scouring, for good side projects and different ways to pick up programming that are kind of unique and help me as self-taught kind of get through some of the challenges of being a self-taught developer, where you need to find a lot of projects on your own. You need to find a lot of online resources. And so one of the things that really excites me about Battlesnake the most is just kind of this opportunity to find a fun side project, something to work on your weekends to really improve your programming skills and get better at a problem, basically. So yeah, a bit more background on myself. I worked with you, Brad, for a while at Send with us, and I've now moved on to working at Amazon Web Services. I'm primarily a back-end developer, so the code that you're going to see today has some CSS bugs and issues that I'll throw out to everyone to try and fix, because I'm not, frankly, very good with UI or CSS at all. But yeah, I'm now working at AWS on the commerce platform team, enjoying that. Yeah, that's pretty much a bit of background on myself.
I think you touched on something. I'll stop the screen share here and we can get back on camera. I think you touched on something that's really interesting and that we see a lot, especially with self-taught or even developers that have gone through like a boot camp or a coding camp or a coding school, where you kind of come out of those situations and everyone says like, okay, keep practicing, keep learning. But there's only so many resources, right? You have to be very self-reliant, and you have to do a lot of self-directed learning, or you have to go, try to get a junior developer job, which isn't always easy. That's a big challenge. And so that's one of the things that we try to do here at Battlesnake is like, we want to give those developers, those sort of like early career developers, a good home to practice new ideas, practice new technologies. You can go really in depth with Battlesnake, and you can really explore some really complex and modern technologies. And we really like that about what we do. And so it's awesome to hear you mention that as well.
Yeah, for sure. Yeah, I think that's a lot of the inspiration for this project that we'll be talking about today, is trying to make it easier for someone who's self-taught to get up and running with something like Battlesnake. I think that one of the interesting things about learning programming on your own these days is there's so many cool frameworks and so many different technologies that you can try. But one of the things that I like about Battlesnake is it's a very pared down form of programming. You're not working with a framework. You're not learning React necessarily. Instead, you're learning key algorithms that will help you throughout the next 20 or 30 years of your programming career, not just the kind of the framework of the day that's gonna help you in the next couple of years. Right. So I think it's a really key kind of the core fundamentals of it are something that will stick with you for a long time, rather than some of the other learning you could do on your own, which may come and go in terms of the new technologies that you have to pick up. But learning pathfinding algorithms, for example, learning to spin up an HTTP server, that stuff's going to be around for a long time.
I think there's a ton of stuff on the deployment side of just learning how to deploy code, right? Like,
yeah,
it's really easy to get a tutorial that teaches you how to code locally in a single file. But in terms of getting that running on the internet somewhere, in a cloud platform or otherwise, and then also debugging that when things go down or when unexpected things happen, or also figuring out how to scale it, right? So if you want your snake to play in multiple games at once, how does that programming look like? And these are problems that are much more analogous to real world software development, for sure.
Yeah, for sure.
Awesome. So super happy to have you on board. Or have you on stream today. Let's dive in. Let's talk about your Learn to Battlesnake project that you've been working on for a few years now, and you can kind of walk us through it, and we can link it in chat. I think one of the mods can get it going in chat, and everyone in chat who wants to could follow along.
Cool. Okay, so yeah, this is a little kind of talk about my journey as a self-taught developer. I spent a lot of time on different online sites that teach you programming, and I think that this kind of setup for Battlesnake is really awesome, where you have kind of some text of a tutorial that you should tackle on the left here, some code that you put in the middle, and basically we have our running snake that's going to be running with the code that we actually write on the right.
Also really awesome ASCII art, right? And just like it's necessary for most tutorials.
Exactly. Yeah, this is how it starts out here. So we'll just go through the basic setup of this tutorial here, and I'll obviously, if you want to follow along on the Twitch chat, just stop us and ask questions at any point. So to talk a bit about the basics of Battlesnake, I think a lot of people on the Twitch chat may know this already, but I'll just go over it quickly. One of the key elements of this is, as we mentioned, you're running an HTTP server, and there's an engine component on the Battlesnake core side that's calling your HTTP server, collecting moves from a set of snakes, aggregating them together, and then advancing positions along the board here, as we see. So what we're going to emulate in this tutorial today is to try and get you up and running really quickly, without kind of some of the boilerplate of building an HTTP server, which we'll do a tutorial on a little later. So this is really your first day of playing with Battlesnake. This can get you up and running super quick, so you understand the concepts, and then you can go on to continue to build your snake and get it running on battlesnake.com, which we'll show you.
One important distinction here is this is all running locally in your browser in this one. So this isn't interacting with the battlesnake.com engine, or you're not creating snakes on battlesnake.com yet. This is purely just for testing and sort of getting a feel for how the game works, how the mechanics work, and writing early stages of code, right? Yeah,
exactly. So the game of Snake obviously is played out over a grid. We really focus on coordinates. So 0 is at the top of the board. Coordinates are a big part of building our snake to understand how the moves work here. So let's get some code in here, basically. So kind of the key way this works here is we're going to have two functions, move and start. These replicate the HTTP calls that would be called to your server. Normally, start would be responding to post/start, and move would be responding to post/move. These both take parameters which would which would be basically the body of the HTTP request that the Battlesnake server would send to you. So I'll just put in here a console.log statement so we can see what's coming out. And we'll restart this game over here. So you can see in my console here, this is what's being returned by our in-browser engine here, which is what we call it. So the engines.
So this is information that you're getting from the engine about the board state for that specific turn, right? And you're getting this, like, basically that move function is going to be called every tick of the game.
Exactly. Yeah. And so this state parameter is really important. This is what we basically use to make a decision on where we're going to go with our snake next. So we have the board parameters here. We have a set of food. We have height. We have snakes in here, all sorts of things about them, different game parameters, and critically information about us. So this is kind of nice if this is your first time kind of playing with Battlesnake. Spend some time clicking around in here, getting a sense of what this means, because this is really the key object that's going to be passed in here, and pretty much every decision, the whole component of your AI is building out your move function here so that you can determine based on the state passed in where we need to go. Obviously up, down, left, or right. So you can see if I just change this here to move left, play the game, my snake will go until it moves off the board to the left here. So yeah, what we'll be playing with today is trying to make this snake actually move around the board a bit better, not just go one direction, go off to the right here.
Before we dive in, let's talk a little bit about. So this is hosted live, right? This is at colinjfw.github.io.
Yes.
There's a link, /Battlesnake-learn. There's a link in the chat if you want to follow along live. And this is also open source. So if anyone wanted to see how you're building this tutorial and the code that's actually running the engine, or the code that's going to produce the Lambda code that's spitted at the end, they can definitely just go take a look at this and get involved.
Yeah, definitely. Come open issues, open a pull request. There's only 1 star, so we should get some more stars on here.
I'm going to go star it right now while you're doing the next bit.
So yeah, so we've console.logged out our state parameter. This is basically everything that we're going to have in it. And again, as we talked about, this is really the key thing that we're going to look at to make our decisions next. So what's going to happen? First step here is we want to avoid walls, right? This is the issue that's continually happening with our snake. We're just running into walls, going left and right here. So we want to build some logic into our snake so that when we get close to this wall here, our snake's going to go up or it's going to go down. It's just definitely not going to run into that wall again. So the first step here is finding the head of our snake. We need to understand that this is the head, these are the coordinates, and then we're going to figure out from there which is a safe direction to go. So this is the first kind of step of really any Battlesnake implementation. You'll see something like this, a head parameter in there. I'll keep the console log statement in there. Also, one kind of cool thing about this, if you've used the editor VS Code, this is the just the editor component, not obviously everything else that's wrapping it. So you have all sorts of different nice linting rules and stuff in here, which is kind of cool.
I think that's a key part of like any, especially online coding experience, right? Is like, give me some niceties that I would have locally, and otherwise it's just going to be too painful.
Yeah, exactly.
I think it's awesome.
So the general strategy we're going to take here is what we're going to do is we're going to grab a set of moves. We're then going to detect, are those moves safe to do, basically. Safe is going to mean in this term, it's not off the board. And we'll figure out the next step after that. There's a different condition there. But first we'll start with, is this off the board? So the first step to doing that is basically translating a move command, like up, down, left, or right, into a coordinate. So a coordinate being our X, Y parameters here, which describe a position on the board. So I'll grab this function, put this into here, and I think hopefully you know where I'm going here, but basically we can run a set of moves over this, get their coordinates, and detect if they're off the board. Off the board it's relatively simple to determine in this case. Obviously, from our coordinates, if x is less than 0, then that's going to be off the board. And then if x is greater than the width of the board, then we're going to also have a problem. And same for y, if it's less than 0, we're going to be off the board. And also if it's greater than the height of the board, we're going to be off. So let's run through this filtering approach. Run through each move, get the coordinate where it's going to be at, and detect if it's actually off the board. So I'll grab this code in here. For every move, we now know where this is going to be. And now we want to add our if statement in
so
here.
What you're doing there is you've got this array of possible moves, and you're saying for each move, map, if I go up, get me the coordinate where my head's going to be if I go up, or get me the coordinate where my head's going to be if I go down.
Yeah, exactly.
And then I understand. Okay.
Yeah, so it's a kind of filtering approach. The one thing is if you don't like this style of programming, if you think that there's a better way of doing this, let me know. Contribute a tutorial. This is kind of just one way of tackling this initial problem.
I think this is a really great way, especially for new programmers or new Battlesnake programmers, right? Is like, instead of thinking about it as like, okay, well, where do I want to go? Start looking at like, well, where can I go? Like what are the possible moves what areas are, what moves are going to get me eliminated, and let's make sure we're avoiding those.
Yeah, exactly. Cool. So I kind of stubbed out our offboard function here, but basically this is what we want to run. If it's not off the board, this is now a safe move. And so we can return the move parameter here that we want to do. And so this is going to be the basics of our function here. I'll just throw that in there. Basically, we check, again, as we talked about, if x is less than 0, if y is less than 0, or if y or x are greater than height and width. There's a bug in here. It's an Easter egg it's probably pretty obvious, but it's an Easter egg for the Twitch chat, if you want to find that out.
If you can see it on Twitch, let us know, and maybe we'll correct it. It took me a second, but I got it.
So let's see how this runs. Interesting. What happened there, Brad? I thought that was going to work.
Yeah, I thought it was going to work too, but it looked like you didn't run off the board. You moved back into yourself?
I moved into myself. That's strange. How could I move?
You tried to go down?
Huh. Let's play with, so this is our second option. Let's see if this logic is working correctly if we change this here. Okay, I go left. That's good. But then I went into myself again. So this is, I think for me, this is kind of one of the initial unintuitive parts about Battlesnake, is that you can actually hit your own tail. But if you think about this is kind of a key thing. Obviously, a tail is, it's a segment actually on our board that's filling the space, so we can't run into ourselves. This would be really cool once you start looking at games that are played by the really good snakes. If they had the ability to move back into their tail, they would just follow the path of themselves all the way back and get out of these crazy situations. So it's kind of a key rule. It's unintuitive, I think, to me initially, but that's what we're going to tackle next. So how would we tackle this conceptually? We're going to use basically the same format here, but we're basically just going to detect is something in the square that we want to move into. Just the same as we're checking, is this coordinate off the board? We want to check, is this coordinate currently filled by something, namely our tail? So we need kind of a helper function in here if coordinates are equal. This is kind of one trick. Obviously, since A is an object with X and Y in it, if we just do A equal to B, that's not going to work for us because the objects may have different references, so they're not going to be identical in this scenario. So we're just have a quick helper function here, which just tells me, are the coordinate values equal here? Is X equal to X and Y equal to Y? Now, what I can do is I can basically look at the next segment in my body, which I'm going to call the neck parameter. I think that's a weird way of thinking about it, but this seems like a natural variable name to me.
This came up yesterday of like, what do you call the parts of their snake that aren't the head? Is it all neck or is it all tail?
Yeah, I like neck. I mean, I don't know what the third segment is. If the third segment's not the tail, is that neck 2?
This is further neck.
Further neck. Yeah, we'll
neck
go with this though.
Yeah.
So now I want to check: is it not off the board, and is it not equal to the neck? So I want to check coordinate. The next place that we're going to be is not equal to my neck coordinate.
So just to make sure I understand. So again, you've got your list of all 4 possible moves, and then for each move, you're saying, okay, what's the coordinate? If I move here, where's my head going to end up? And then you're asking, is that on the board, and is that not my neck? And if those 2 things are true, then you're going to take that move.
Then this is a safe direction to go, basically. Exactly, yeah.
Right.
So let's see what happens. So we go over to the left there. We go over there. And at the critical point where it ran back up into itself, this statement didn't pass here. And so we return this as a safe move to go through.
Got it. So now you are correctly avoiding all, like you're avoiding staying or moving off the board. You're able to stay entirely on the board, and you're going to move in directions that aren't your neck. And so this snake just live in, I guess it'll run out of health at some point?
Yeah, in the kind of the browser version of this, there's no health implemented. So this is kind of one difference from the real Battlesnake engine, is your snake in the real Battlesnake engine, it won't survive for an infinite amount of time. Instead, it starts with a specific amount of health, and you would get, I think it's 100, right? Yeah,
it's currently 100.
So you would get basically 100 turns without eating before you'd have to eat one of these red dots here. So this will continue to just loop around forever, but we can maybe deploy this and stick it up on a real Battlesnake game, and you'll see that it's not quite yet a sufficient algorithm in many different ways to survive in the real world of Battlesnake. But this is pretty good for this. If you can get to, I think if you can get to this and understand what's going on for your first day of Battlesnaking, or even your first week, month, whatever your skill level, this is a pretty good state to get to. Just know there's much more entertainment to come.
So I am curious, before we move on to the next stage, like, why is it sticking to that left side? Like, what about this code? Because obviously there's like a very repeated pattern here. I think regardless of where you start, your snake's going to end up in that loop, right?
Yeah, for sure. So I think this is one of the first things that you would do to start modifying this code is you would have a set of things that you're actually aiming towards, right? This is a basic algorithm that's just moving in the first safe direction. That's actually it's a decent, fallback algorithm. And a lot of snakes will kind of be coded with this in mind, but maybe the first thing that they want to do is they may want to pick like a direction to head into. So we, look for something like a food item, like state dot. You need to go in here. It's board dot food. So they may want to pick this and see can I get here? And then if they can get over there, then they would try that, and then maybe if not, they would fall back to just the safe option. So it's kind of a shift of just, we're just trying to survive. We're just trying to pick the next option. We're trying to do something active. We're trying to go towards some food on the board. We're trying to maybe attack another snake.
I think a really, okay, so just riffing on that for a second, I think an interesting way to evolve this is if you leave, where you've got line 10 onward and just kind of leave that alone, what you could do is you could reorder your moves to check moves that are going to move you closer to food first. So like the first piece of code is just like, here's my preference. I would rather go up than left than down than right, or here's the order of moves that I want to check in. And then I'm just going to go in the first one that's safe based on that order.
Yeah, so we could even have not change this significantly and just have basically something that's like select moves. A function here, maybe that would take in our state parameter.
Or like prioritize moves, right?
That would prioritize our moves that we want to take here. How would we prioritize moves?
I'm trying to think that through now. So like, what you'd want to do. Okay, so if you're going to do this, I'd want to look at the first piece of food. And I'd want to see which of those moves gets me closer to that food. So first food would be like whatever the first food item is on the board, and then for each move, you measure the distance between you and the food?
Yeah, that could work. Because then if you're... I think, that would... I think, because if you're a distance 1, well, you would want to take the coordinates after you'd made the move.
Yeah, like you'd want to, it'd be a similar process as what you have in your main loop, right? Where like, for up, down, left, right, give me my distance from that, where my new head is going to be, right?
Yeah, I think that could work. Yeah. So something like this, it would be like, what is that? Move as chord.
It's a move as chord, yeah.
Move. And then...
You're going to have to find your head again.
I want distance. I'll just pass in head as a parameter there. Distance from... so I want to go give it... I actually don't need my head because we're... Oh, yeah, I need...
you need it to get the move as chord.
Right, move head. Yeah. And then I want distance from coordinate to the first food.
Yeah.
And then I need to do some filtering logic here.
So that part, this is where you're better at JavaScript than I am.
I know. I'm trying to think of how the built-in sort function works.
Yeah.
I think what's a quick hacky way I can do this? I think I would.
You can map like the distance could be your key.
Yeah.
In an object, and then you sort keys, and then you grab it.
I was trying to write some like nice. I think I don't know. We can Google how sort works in JavaScript, right?
Yeah.
This is how real programmers do things.
This is real programming.
Not W3 schools. Compare function. First, second. Okay. That's pretty simple. So we could do something nice like moves dot sort. our function. And let's do distance. A first food. That would be pretty cool if that worked.
I think that works. Yeah, I agree that it would be cool if it worked. We still prefer a distance function.
Yeah, let's do the distance function, and then if anyone's good with JavaScript on the Twitch chat, help us out here.
Yeah, tell us where we're wrong. I think Brandon's kicking around if he's got some ideas. Distance function is what I've been thinking about. So you can go like full Pythagorean theorem if you want to do distance between two coordinates.
Yeah, exactly. That's what I was thinking too.
Yeah,
that's something
which you can probably just Google. Yeah, or you could. There's hacky ways you could do it, right? Where you take like your delta x plus your delta y and just treat that as an absolute distance. Because technically that's how many moves you have to go to.
I did this wrong.
You have to go through.
Let me fix this first. This is head.
Right.
So yeah, we're taking in distance is taking in a coordinate here, and then we're
it's
going
like chord
to the
1 and chord
here.
2, right? Yeah.
Yeah.
So you don't even need to do like you can do like delta x plus delta y, right? So chord dot x.
That's true.
Yeah. Because technically, because you can't move on the diagonal anyway. So what you really want is number of moves away, right? Which is delta x plus delta y. But you also want the absolute values of those. So it's like abs, chord x minus food x.
Yeah. This is a good. What is this called? This is there's a specific name for this, right?
The absolute. I don't know.
On grids, isn't there a name for this exact function?
Yeah, but it's not like. Yeah, I think it's path length or something like that, right? Because like that's the math you're doing.
Yeah.
You're not doing distance from your head to the food. You're doing how many moves am I away from the food?
Yeah, exactly. So let's see if this works.
Is that what it is, Brandon? Brandon in chat says Manhattan distance.
Manhattan distance. Yeah, I think that's the one. This is a really this is really useful. Here, this is a nice point. I'll do some talking to first a bit here, because I think this is a really important point to emphasize. It comes back to my idea about like the importance of Battlesnake and being able to teach some of these fundamental concepts from programming that you may not learn, especially if you're self-taught, or maybe you didn't do a full computer science degree, or maybe if you did a computer science degree but you forgot all of this because it's
because
it's been a while. Yeah, I think this is a really cool way of refreshing your memory on some of these really important things. This is something that will pop up in tech interviews for sure, right? So it's useful to kind of apply these things in a fun way.
And now I just want to see if it works. I'm so excited.
Select moves. I need head state. What? Well, it did not work, but
what is it?
Console log. Let's just remove this for a sec.
Classic debugging.
It's just returning the same up,
It's not
down,
actually
left,
sorting
right.
it. Yeah. Is it because does moves.sort return a new? Is this stupid? Does move.sort return a new array, or does it sort it in place? It returns a new array. No, or the array is sorted in place. No copy is made, but you've also got it as a constant. So maybe it's not sorting it. I don't know. You're better at JavaScript than I am.
Yeah, let's see. Oh, crap.
Oh, that'll do it.
I've been programming in Ruby lately. Oh, look at that.
Oh.
What?
Oh,
wow.
Yeah. Oh, wow. We're going to get all the food.
This is the highlight of my weekend, I think. Oh, crap. Damn it. Should have stopped it before it aired.
It's amazing. Yeah.
Yeah. So, yeah, I'm making an assumption here that food exists, obviously. We can fix this pretty easily. So, if not first food, we're just going to return moves. And then there we go.
I think it's still
select the first option.
Still my error out. Because the state.board.food at 0 is going to... Well, never mind. Okay, it worked.
Oh, now we hit ourselves. Yeah. So this is actually another good lesson here. So when I was checking if we're going to hit ourselves, I kind of made an assumption that we can only run into the neck of our snake, right? But in this case, there's obviously a lot more snake to run into, namely this segment right here, right? So that was the problem here. Is the algorithm was detecting, are we going to hit this guy here? But we ran into this guy over here. So this check here isn't sufficient. What we would actually want to do is we would want to run this check over basically all of the segments of our snake and also all of the segments of other snakes. This is where it gets kind of interesting, and make sure that we're not going to run into a component where we're gonna die, basically.
You want to try it? You want to see if you can code that out?
So I'll make it simple function here, like function will hit self. This won't handle other snakes for the moment. And we'll select, this is going to take in a coordinate, but instead of just this being the neck that we're checking, we're just going to check the entire segment of our snake. So basically, there's another cool JavaScript-y stuff we can do here. Is there like I'll just do it the simple way. I'm sure there's some cool like JavaScript map function that returns if none of this is true for that, but I can't remember it.
Yeah.
We'll call this segment of our snake. So for every segment of our snake, we want to, if coordinates are equal, our head, the next head we're going to be at is equal to the segment. We want to return false. And if not, we return true.
Is that, have I got that backwards? If they're equal, you want to return true?
We'll hit, that's true.
There we go. Okay.
I could be, So if I will hit myself, if the next move I will make is equal to a segment of my body. That's kind of the way of describing this here. So I should be able to just plug this in. If not, we'll hit self. I changed the order of my parameters here. Coordinate, and then instead of passing my neck, I want to pass the entire body here. And this is now unused.
Awesome.
All right. Are we taking bets? Do we think that'll work?
I think we got it. I think we're good.
Well, it hasn't errored, so that's good.
There's still time.
I think it follows a very deterministic path, so it passed.
Oh, there we go.
There we go.
Oh, cool. This is great. Okay. All right. I mean, that wasn't bad. It took us like 30 minutes, 40 minutes to get here?
Yeah.
And I think in theory, this snake will live forever, right? Because it's going to seek out food and it's not going to run it. On its own, it's going to live forever, I think.
I think on its own, it will live forever, yeah. It won't. The one aspect that probably should be added is will hit self should be extended to will hit self or another snake. That's like the next kind of additional thing, because as soon as we put this on a board with another snake and a snake is beside this one, just in a line, it'll just run into that snake that it's beside because it's not actually inspecting that.
Right.
All
right. You wanna try to get it live? We'll run a real game and see what happens.
Yeah, let's do the deployment step here. So, congratulations. You've made it through the tutorials and some extra part here. So what kind of the concept is here is what I wanted to do is take this actual code that you wrote here, be able to download a really fast and easy just zip file with the code, short README in it, and so we can ship this and actually deploy it to Lambda, Heroku, or hopefully a bunch of other platforms, which we'll add in here. So if we just hit AWS Lambda, should download a zip file, and I will switch over to here. I'll just copy. I think this is in. Gotta unzip it first. Lambda-3. I'm just grabbing the zip file and copying it into a local directory here so that we can inspect it. Let's just see. There this is here. So what you'll see in index.js here is basically all of the code that we just wrote, along with kind of some wiring here to wire this up for AWS Lambda. So it's all one file. It's all really simple. There's nothing changed here. It's just basically the key aspect that's different is we have a really, really basic HTTP router that's just going to route move requests, as we talked about initially, to our move function that we just built previously. And also the start request so that we can set the color of our snake. So if you download this, there's nothing new really added in here. It's just this additional wiring to wire up our snakes so we can play with other snakes, basically.
And yeah, this is all in the open source repo as well, right? So if anyone wanted to go look at what code specifically you're adding and what it's doing, they could check it out there.
Yeah, it's all in here. We just kind of zip it all up in the browser, so you can see the different platforms here. Lambda, this is the template, and we just basically concatenate our code in front of all this. Yeah, add contributions if you think there's improvements that could be made to this as well. Okay, so Lambda 3. So now we want to deploy. So I'm going to deploy to AWS Lambda. If you haven't used AWS Lambda before, it's really similar to Heroku. Probably a lot of you have used Heroku. It's kind of the AWS version of that, and one that kind of scales without necessarily thinking about dynos or servers in certain concepts. It just kind of scales to however many requests you're taking in. One of the nice things for Battlesnake is it's an infrastructure where you're not paying if it's not being used. So especially for test accounts and things like that, you can have many different versions of your snake running. You can have, leave an old snake around for years, and as long as no one's hitting the infrastructure, you won't be paying for it, which is kind of cool. So once
you also get, there's like AWS free tier. There's some minimum amount of usage that you'll get for free as well. So the likelihood that you'll have to pay any real amounts of money to power this is very low.
Yeah, for sure. So yeah, I'm going to be using the AWS serverless application model, which is kind of just a basic CLI that allows me to run a deployment here. I have some template parameters here, like a serverless function that will basically deploy my index.js file up with some different parameters here. One of the other interesting things, which you don't need to understand too much about, but I'll mention, is this is provisioning an API gateway behind the scenes. Basically, I think of that as just a resource that's basically taking my Lambda function, taking my code, and connecting it to the internet. Is a simple way of saying it. So I'm going to run this deploy command here. I've run this a few times, so I'll name it Battlesnake v3. With the guided, it just asks me for various things. And you do need to have an AWS account set up with credentials and everything before you do this. You just answer yes to everything. Cool. And now
so this is taking your function now that you built through your tool that's hosted online, and it's getting it up on the internet behind a URL that you can then use to play the game.
Yeah, exactly. In my AWS account.
In your AWS account, right. Awesome. I'm always impressed with how fast the Lambda, because you're not even deploying Lambda, you're creating all these resources for the first time too.
Yeah.
Heroku is really fast, but Lambda is also almost equally fast.
Yeah, it's quite quick. It's not, if you don't need to build databases or anything like that, those obviously take a bit longer. But if you're just kind of deploying this basic level of infrastructure, it's going to be pretty fast. The other thing that's cool, we'll check this out immediately. So I've deployed something, and you're wondering what that looks like. There's a few different ways of inspecting this in the AWS dashboard here. This is the CloudFormation stack that this serverless application model created. If you don't understand too much about that, that's okay. This is a really complex tool that can take you quite far. But the important thing is it's kind of abstracted by us. We built this simple model, so you can go as deep into this as you want, or just stay on the surface level here. The important thing is to get over to your Lambda function resource from CloudFormation here, and then get to this part, because this is really cool for you to have. So you just have an editor with your code in this, and we can play around with this, fix bugs immediately, and just hit save once we change some code there, and that'll be deployed pretty much immediately, which is really nice, especially if you don't want to set up a whole editing environment and deployment CLI for this.
I think that's one of the nicest things about this tutorial in general, right? Is your first step is all sort of done in browser. It's still it's an embedded VS Code browser, but it's not something you have to worry about or install or run locally. And then the second part could be entirely done through the Lambda console. So there's no requirement other than the Lambda, the AWS CLI tools to get the Lambda deployed. Once you're up and running, there's no requirement to actually run anything locally. You could edit entirely within AWS's UI, which is awesome.
Yeah, exactly. So now we want to find our endpoint here. This is probably the trickiest part. Just to find your API gateway endpoint, you want to find the ID here. And then just in the README, I have a little spot where you can fill this out just with the ID value there.
Awesome. So, all right. So that should be live now. If you plug that into a browser, you should see something.
I don't know what happened. Yeah. So let's do a quick curl command to test this. We'll test the start command here. So I'll copy this, curl. Cool. So that's our snake, right? This is kind of bringing this full circle. This is exactly what's being returned. Just some JSON is being returned from the start function here. We've just wired that up to respond to.
You know what we should do?
/start.
You know what we should do before we actually create a live game with this is we should change the color, because that white snake is not going to play well on the whiteboard.
Oh, cool.
You could run that direct in Lambda, right?
Yeah. What color would you like?
I don't know, what color does chat want? You always gotta let chat decide these things because they're very picky. We'll see if anyone says anything. And then while we're waiting, we can talk about this color parameter. This is just a CSS color code, right? Like, you've written the word white, but white doesn't. It's just passing that to the browser, and the browser is going to paint it however it interprets that string.
Mm-hmm.
So you could put like a full hex code in there if you wanted to.
Yeah, we could put green. We could put EEE.
All right, I think we're going with purple.
Oh, okay.
All right.
Purple. Save, and that should be deployed. Let's check it out on our curl command here. I'll push this up in a second. Great. So we have purple coming out.
Awesome.
So now, let's make this snake. So go over to create Battlesnake. This is an important part. If you have the /start in there, it'll ping your snake at /start, which then won't respond with anything. So it's probably an easy way to mess things up. Just make sure you have the right path in there. Yeah. Battlesnake learn Twitch tutorial. Yeah, you guys can add this snake if you want.
Yeah, you can make it public, and then if you're live on battlesnake.com, you could technically add this snake to your game right now if you wanted to.
Okay, let's see how it works. Should we add in maybe my other snake?
Let's run it by itself first, right? Because in theory, this thing goes pretty far.
That color's not right.
That color's not right.
I'm going to say that's your fault, not
probably
mine.
Probably my fault. I'll take it.
Oh, it hit itself.
Can you zoom out a bit in your browser?
Sure.
Yeah, there we go. Now we can see the whole board.
So
all right, let's run it. Let's see what happens.
So that ran pretty well. You could see it boxed itself in. It doesn't have some smart logic to figure out, I shouldn't go this way.
Right.
So it got itself boxed in.
So from this position right here, like your two options are left or right.
Yeah.
And it's probably going to go left because that's closer to food, right? Which is what it's going to look at.
Exactly.
And then it goes left, but then there's no intelligence that we've written to like look further ahead than one square. So it boxes itself in. It's going to keep moving into empty squares until it eventually has nowhere else to go.
Yeah, that was a pretty unlucky first game, to be honest. It probably should have run for a bit longer. Yeah, that's looking better. There we go.
Pretty good.
Oh.
There you go. Same deal. Yeah. You got boxed in, but this is the progression, right? It's like now you can start thinking about, okay, well, the algorithm is working. The problem now is that you get yourself into situations where there are valid moves, there are safe moves, but they're not going to be safe, 3 or 4 or 10 turns from now.
Yeah. I think that's where that's one of the most interesting components about Battlesnake is like, you really have to approach that with like kind of developing a concept. Like what concept is my snake going to have? What's the really high level algorithm going to be? You can kind of build additional little logic to say, okay, if it goes, you can watch all these games and build these heuristics that say, okay, if it's in this specific scenario, I want it to go right. But if you come up with a really high level concept, like, maybe weighting specific squares or playing the game ahead a few squares and seeing if your snake lives, right. You can get, I think that's where some of the best snakes get their skill from.
Well, I think and there's maybe we're definitely not going to be able to do it live, but like there's an extension to the code that you've got, right? Because you've got you're looking at one move and you're able to look ahead. So if you wanted to, you could take the move that you've decided, and then you could be like, okay, if my head is here, where are my safe moves? And you could see if there's any safe moves resulting from that position. And then you could expand that to a certain degree and start looking, n moves ahead.
Yeah.
Basically using like the same, you could, write turn what you've got into some level of recursion and try to go from there.
Yeah, I think that's one of the coolest parts. And that really gets you into thinking about timeouts, how long you want to run that recursion for, and stuff like that. Okay, let's see what happens with another snake on the board. Ooh, so we hit that initial problem that we knew about, just that we're only checking for our own snake segments. So this is a really easy one to fix. We just want to check for C-SNEX segments along here, basically. But that's pretty good. This is pretty good. Oh, awesome. I'll hit create rematch. We'll watch a couple games here. I think purple is not a valid color or something.
I think it has to be a hex code. I think the engine's verifying that it's a valid 7-character hex code, and so it's just giving you random results.
Oh, okay, cool. Huh.
I think that's what's happening. It's probably what's happening with C-SNEC too. Cool. Yeah, this is great. The other thing we should talk a little bit about the board. Just looking at the scoreboard here, if you can run a few turns, and we'll see. So the scoreboard shows health. That the colored bar is how healthy your snake is. The bigger number is the length. So you can see C-SNEC here is 6 squares long, and our tutorial snake actually got 8. So it got to be longer than C-SNEC did. And then the other number that you see on the scoreboard is actually the round trip latency. So that's how long your server's taking to respond to the game engine. So that's where Colin we're talking about. Yeah, that's really cool. We added that in the last month or so. Huh. So Lambda is actually pretty fast, right? Especially like Heroku, we typically see low hundreds. But Lambda, you've got a ton of time that you could play with. So you could get pretty creative with your use of recursion here if you really wanted to.
Yeah, that's really good. That's also running right next to your infrastructure as well. Same data center, effectively.
You're in Oregon, US West 2.
Yeah. So if you do run this, make sure that you're in Oregon. You'll get better latency that way. Cool.
Awesome. All right. We'll see if there's any questions in Twitch chat before we sign off here. I think this has been one of our better tutorials so far.
I think
I'm really
it was
happy
good
that we got
because
it finding food. Yeah,
I think it was good because it worked. It also could have gone in quite a different direction. So yeah,
I think that's awesome. Yeah, cool. So let's just do a quick review. If you wanted to, if you could show your tutorial again. Talk about where it is and show the open source, and then tell people where they can find you online if they wanted to ask questions.
Yeah, so just hit up colinjfw.github.io/battlesnakelearn. The GitHub repository is the same. I guess we'll paste these all into the Twitch chat as well.
Yeah, one of the mods will pick it up.
And give it a shot. I think it would be really cool if we kind of extended the tutorial. I'll save this code here and I'll try and extend the tutorial with what we put in today. And yeah, if you want to talk with me, that's me here. That's me on Twitter. So yeah, feel free to reach out with any questions or anything that you have.
Awesome. All right. Well, thanks so much for joining us today. I think it's been great. It's been a lot of fun sort of live programming with you. All right. Thanks again, Colin. It's been a lot of fun, and we'll see y'all later.
See you, everyone. Thanks, guys.